analysis of flower classification machine learning implementation. Next, please. We will go through 6 major things and finally a conclusion. Next, we will tell you more about our project.
So the overview of the project is divided into two tasks. The task one is to classify the image from user input. The task two is recommend 10 picture from user input to user based on the image. And the expectation for this is write a comprehensive report about the machine learning model and moreover develop a machine learning model to address task one and task two. Next, we moving on to literature review. So the literature review will divide it into three steps. Step one is identify the problem. So the project address a unique problem that modern societies face in the real image recognition, first especially flower identification. User can easily capture image of flower, but identify this flower can be challenged. So this project proposes an image-based researching function that allows user to upload image of flower and the system powered by a machine learning model will return a list of similar flower. And in step two is generate solution. First, we research about model skimming dataset. So after skimming and research about model, we found that convolutional neural network and random forest artificial neural network is compatible with the project because CNN are particularly adept at capturing spatial hierarchy and local global image feature, making them well suited for image-based tasks. So this inherent ability of CNN can potentially allow users to identify flower from image with higher accuracy and reliability. And moreover, there are several key that we found in. First, the project use image reprocessing pipeline, which is cleaning, globalization, resizing, and augmentation, which we have to differentiate programming because each model requires data processing differently. And in terms of problem solving, next we're moving on to the next slide. So our approach first is we choosing a model and then we choosing how to reprocessing my data and metric. So for the model, we have to research about machine learning model and choosing the right model for our project. And then we moving the past lecture to find a content about data reprocessing and metric. And in the reprocessing data, we are skimming the data set. So we can see that the dataset whether have been corrupted or maybe missing image or the image it cannot be read by the computer. So then we can develop a code that um, cleaning the data. And then we're setting a performance metric to evaluate the model. So we can test like accuracy or maybe classification report, which is used to find the best model for the project. Then for other comparison, next slide please. We found that there are three similarity and three differences from other research. First, the similarity, they all use convolutional neural network, which is many image recognition or classifying project use because it's capturing local and global feature in image. Moreover, this technique allow model to understand and categorize complex pattern within image. Moreover, the processing data is very crucial in every part. And then the performance metric, we both use the same type of processing data and performance metric. And for the differences, because the project is very narrow, so it's very specified in subject matter, and the image based search because it in the folder symbol data there is no corrupted or maybe the size of image is very fixed. Moreover, the all image size is GPG, which is easy for computer to train and predicting the and classifying the image. And in our project, we don't use no chain for learning because it's very not compatible for the project. Next, we're moving on to the critical analysis.
I think, thank you, Huy. In task one, we are doing the flower recognition. In this start, we have developed three models for flower recognition: artificial neural network, convolutional neural network, and random forest. Each model has its strength and weakness in accurately classifying flower type. The data set we use are preprocessed data by resizing, scaling, and normalization the given image. The goal for this task is to choose out the best model based on their accuracy. Next slide, please. Can you move on to the next slide? Hello?
Already.
The accuracy of the random forest model is around 0.436. With its decent, the accuracy of the CNN model is around 0.624, which is better, much better than the random forest model. And the accuracy of the INN model is 0.435, which is worse than CNN model. Thus conclude that we will choose the CNN model for this task. Next slide, please. For task 2, we do the same. Our goal of this task is to recommend a similarity image of the flower that the user put in. The model we use is a modified pre-trained model from task 1, which use the same data set of we utilize a pre-trained CNN as the feature extractor to capture the relevant image feature. To evaluate the model's performance, we create an evaluation data set with round-true similarity. The evaluation data set consists of input image and their corresponding round-true similar image. Next slide, please. Next, we will tell you more about this project.
And for the future development, our team will try to finish the task 2 in the near future and try to improve the transfer learning for the task 2. And furthermore, we will try to implement online learning algorithms to the projects to help the projects to run on larger scales continuously. For transfer learning, the project can be extended to leverage transfer learning from related domains or pre-trained models. By utilizing models trained on large-scale data sets, the project can benefit from pre-learned features and knowledge. This approach can save computational resources and improve performance, especially in scenarios with limited label data. For online learning, algorithms, by implementing it, the project will continuously adapt and learn from new incoming data. And this is particularly useful in scenarios where the data distribution evolves over time or when there is a need for real-time decision making. And to conclude, the project aimed to implement a machine learning model that would enable users to search for flower types based on images. Comparing the efficiency between three models, we found that the convolutional neural network CNN proved to be the most effective model for this task, superior to both artificial neural network ANN and random forest RF. And for future development, we will try to implement more algorithms to the project to help the projects to run on larger scale and to improve the performance of the project. And that's our presentation. Thank you for listening.